Hello, geometry class. It's time for us to continue in our notes, and this is section 1-4. After this section, you're going to have a day of review, and we are going to have a short quiz over these three sections that we've covered thus far. But first, we do need to talk about measuring angles. So first of all, what is an angle? Well, in technical terms, it is two rays with the same endpoint. So notice here, which this isn't drawn super well, but there is a little arrow right there. We have ray AB and ray AC, and they both share this point, and so they're forming an angle right in here. There are two ways, I guess technically three ways, that we can name this angle alone. We can call it angle A, and notice how this is the angle symbol. It looks really similar to the less than symbol, so I always try to make sure that the bottom of my symbol is pretty flat so you can tell the difference when I'm writing it. Or you can name it by points on the angle, so BAC, angle BAC. And of course you can go the opposite way, so angle CAB. Something that I want you to notice though is that the A, or the vertex of the angle, is always in the middle. So the shared point is always in the middle when naming it. Okay. Now, just like segments, angles are able to be congruent as well. So two congruent angles are two angles that have the same measurement. So an example might be like 30 degrees and 30 degrees. Okay, when we are denoting congruent angles, we, just like the tick marks with lines, we use kind of arch bends with this. So we can say this angle is congruent to this angle. I try to make them not be completely lined up so you can tell that there are two different sections that I'm trying to kind of mark. Now these two guys might not be congruent to these two, so I'm going to put two kind of rainbow marks on those so I know angle A is congruent to angle B and angle MFG is congruent to angle GFH. In this image right here, what I want you to notice is that I cannot just call angle F congruent to angle F because I don't know what that represents. Does it mean the top half, the bottom half, or the whole thing? So if there's ambiguity, then you have to be specific and use 3 points to label your angles. If I wanted to say that those two things were congruent, I would say angle MFG is congruent to GFH. Now these angles over here, they're off over to the side. It's very easy to tell this is angle A and this is angle B, so I can just write that easily. Angle A is congruent to angle B, and then call that a day. Okay. Now these other words and definitions I am sure that you have heard before, but let's just go over them really quickly, and I'm not going to spend a ton of time on them because I know that you've heard of these words before. First of all, an acute angle is an angle whose measure is less than 90 degrees. I'll draw a little image for you. that would be an example of an acute angle. An obtuse angle is an angle whose measure is greater than 90 degrees. And an image of that for you could be this. A right angle is an angle whose measure is 90 degrees. Now, something that I do want to let you know, unless it is written out in words or in the image, you cannot assume in a picture that an angle is 90 degrees. You have to either be told or you need to have the little box in the corner letting us know that that represents a 90-degree angle right there. Because for all we know, it could be, you know, like 89.9 degrees and just be barely off. So we always need to make sure that we're including our symbol if we're working with a right angle. A straight angle, something that people sometimes forget or don't realize. A straight angle is an angle that forms a line. And equals or has a measure of 180 degrees. So yes, even straight lines are angles. Just so you can kind of see what I mean by that, I'll just do this ABC. This whole angle across that is 180 degrees. Okay. So I know that you've heard of at least these guys. Straight angle might be a little different, but it's literally just a line. It equals 180 degrees, or half of a circle. So now we have the angle addition postulate. This is very, very similar to your segment addition postulate that we talked about yesterday. If you have two things that compose a whole that is larger, then you can add them up and you can get the whole. That's basically what we're about to say here. But we're going to make it a little bit more technical in mathy terms. So if point B is on the interior of angle AOC, then the measure of angle AOB plus the measure of angle BOC is equal to the measure of angle AOC. Okay, let's bring that and put it into an image for us. This angle right here plus this guy down here is going to add up to get us the whole. So let's just put some numbers in there so we can kind of see. Let's say this one were 10 degrees and this one were 21 degrees. Then we can say 10 plus 21 is equal to 31, or the whole. So that's all that's saying. The only reason we're saying B needs to be on the inside is if B were out here or like on either side of that angle, then we would need to use a different type of setup for that problem. We also talked about things that bisect, midpoints, bisectors, things like that. So angles are able to be bisected as well. So an angle bisector, you guessed it, it is a line or a segment or a ray that divides an angle into two congruent halves. I'm going to say it again. Congruent means equal measures. So I'm going to draw an image of this for you. Let's say we have an angle like this, DOG, and I'm going to put a ray in here, OH. Okay, well now this angle is congruent to that one, so I know that OH is a bisector, or an angle bisector to be specific. To write that out, angle DOH is congruent to angle HOG. This is saying an angle's measure is equal to another angle's measure. If I wanted to write that out with an equal sign, then I would need to say the measure of angle DOH is, I accidentally miswrote that, is equal to the measure of angle HOG. Okay. That is everything as far as vocabulary goes, and hopefully quite a few of them you already knew and you were familiar with, like adding things and bisectors, because you heard about that yesterday. Let's put it into a little bit of practice. So it says, name the angles to the right in as many ways as possible. All right. We have letters on the lines, and then we also have numbers within them. That's not saying that this is 1 degree. We're just calling this inside right here angle 1. So I'm going to go ahead and write that out, angle 1, and we have angle 2. We also have angle ABC. Or we have angle CBA. I can't just say angle B because that's not going to be clear enough for us to know what's going on there. If I wanted, I could put another point out here. Let's call it H. Let's just do a couple more for practice. Angle ABH would be the same thing as angle 1. Or HBA is the same thing as angle 1. What I want you to notice, though, the B is always in the middle, once again, because that's the vertex of our angle. Or we have angle HBC or angle CBH. All of those work. So this is just naming angles and kind of practicing and making sure we're getting our order right. Okay, now we have a problem using a protractor. It says use the protractor to the right, find each measure, and classify each angle. By classify, it means is it acute, is it obtuse, is it a right angle, yada, yada, yada. Okay, so first measure of angle WXV. So we start at W, go to X, then go to V. I will try to kind of highlight which is which. Now, what I want you to notice is on the inside of the protractor, the bottom row is going from right to left, from 0 up to 180. So we can start here and go up. And on the left side, it's on the outside of the protractor, going from 0 to 180. So that's kind of helpful to us. It's really the same measurement, it's just going in opposite directions to help us measure angles a little bit more easily. So this is going up from 0 to 30 degrees on the inside of the protractor, so I'm able to know that's 30 degrees. If I used the outside, it would be from 180 to 150, so then I'd have to subtract those numbers and get 30 still. So we know that this one is 30 degrees, and 30 degrees is less than 90, so it is acute. Now we have ZXW. I will use pink for this one. From Z to X to W. Okay. I'll use the outside for this one. So it's starting at 50 and it ends at 150. So what we can do is take those two numbers and subtract them. So 150 minus 50, and that's going to get us our actual numerical value, which is 100 degrees, which is going to be obtuse. Finally, we have yxw. From y to x to w, that angle right here. Okay, well, I'm going to use the outside again, starting at 0 on the outside, and it's going up 10, 20, 30, all the way to w, which is 150. It's at that 150 mark on the protractor. So this one is 150 degrees, and we know that's greater than 90, so that is going to be an obtuse angle. Okay, those were kind of simple. Let's go ahead and get in a little bit more complex a problem, so nothing too awful bad. It says the measure of angle DEG is 115 degrees. So from D to E to G, the whole thing is 115 degrees. So I'm going to label that like this. Okay. Then it says the measure of angle DEF is equal to 48 degrees. So from D to E to F, so that's this little section right here, 48. I want to know the measure of angle FEG, so this little section right here. Well, I know the total, and I know part of the total, so I can take that part, subtract it from the total, and get the remainder. This is the angle addition postulate. So I have 115 minus 48. Those are degrees. I'm bad about dropping my symbol. And if you need a calculator, that's fine. I already worked mine out ahead of time, and I get 67 degrees for my answer. Okay, the last one, no image, so we might need to read through this more than once so we can draw it out and know what we're doing. So it says KM bisects JKL. And this is not, doesn't have a symbol. We can put a little symbol in front of it, whatever. KM bisects angle JKL. The measure of angle JKM is equal to 4x plus 6 degrees, and the measure of angle MKL is equal to 7x minus 12 degrees. Find the measure of angle JKM. Okay, kind of wordy. Let's just break it down. We know that KM is bisecting an angle JKL. So let's just write out or draw an image of JKL real fast. So J, K, and L. And because the K was in the middle, that's how I knew to put that vertex right there. KM bisects it. So my image isn't going to be perfect, but I now know that this half and this half are equal to each other. So I put one arch on both of them. I know JKM, so from here to here to here is equal to all of this. So I'm going to label that. 4x plus 6 is the top half. And the bottom half, measure of angle MKL, is 7x minus 12. Find the measure of angle JKM. Okay, so first of all, we're going to have to figure out the value of the variable before we can find the value of an angle. But because this measure is equal to this measure, I can set this expression equal to this expression. The only reason I can do that is because it says bisects. Bisects is letting you know you are forming two equal values. So that's a very helpful word, and it should be giving you a clue. You're probably going to set up two things equal to each other because something's getting bisected. All right, so I'm going to say 4x plus 6 is equal to 7x minus 12. Once again, the only reason I can do that is because this half is congruent to this half, and congruent means same measure. Okay, now I'm going to solve for x. So I'm going to add 12 to both sides, and I'm going to subtract 4x from both sides. I'm doing two steps in one. My 12's cancel and my x's cancel. 6 plus 12 is 18, is equal to 3x. Divide by 3 on both sides, and I get x is equal to 6. Woohoo! Okay, if you stop here, then you're not going to finish the problem. You'll only get half credit. Notice what it asks. It asks for find the measure of JKM, which is from, it's this section right here, half of the angle. So what I need to do is take this x equals 6 and substitute it back into my expression. So I have 4 times 6 plus 6, which is going to equal 24 plus 6, which is equal to 30 degrees. And we are done. Hopefully this is all making sense for you. As always, have a great night, and I'll see you tomorrow.